Okay.
And your u is the natural log of, I don't know if that's phi or phi, whatever. So when you do use substitution problems, you have to take a derivative.
Okay.
And there's always a d whatever your variable is, so in this case d phi or d phi in this case, and then you solve for this whatever this d variable is. So solve for d phi in this case. So it's phi du equals d phi.
Okay.
Anything I've done, is this okay? Because it looks like a bunch of these are use substitution problems.
Yeah.
So
Yeah.
that's okay. Okay. All right. So then the next step is to put this back in. So it's the integral square root of u over phi, and then instead of d phi, it's phi du. And we have a choice here. We can either replace the bounds, which we probably should do. Do you remember doing that in class?
Yeah, I think so.
Okay, so the u of 1, that's the lower bound, means to put 1 in for this variable. So it's the natural log of 1, which is 0. So the lower bound becomes 0. The upper bound is u of e, which is natural log of e, which is 1. So the upper bound is 1. So I took those two numbers, put them into the u, and get this. So what's nice here is that these all cancel. A lot of stuff cancels here. So the phis cancel. And it's really the integral from 0 to 1, u to the 1/2 power du, because the square root of u is u to the 1/2. Okay, so this is power rule. So it's u to the 3/2 over 3/2 evaluated from 0 to 1. So this is 2/3 because this on the bottom comes up and flips. Okay, and then you evaluate the top. You evaluate the top limit, so it's 1 to the 3/2 minus 0 to the 3/2. It ends up just equaling 2/3. Because anything to the power of, or 1 to any power is 1, and 0 to any power is 0.
Okay.
And there's a lot there. So that is, yeah, I mean, that's,
Okay.
leave it at that.
Okay.
Okay, B, move on to B. All right, so B is another u substitution. If it's not clear why, please let me know so that I can explain that further,
Okay.
if that matters. But the
Does that just mean that you're using u to plug in?
you can't, like, there's no known formula for this as is. So this technique of integration allows you to turn it into something that you do know.
Okay.
And the reason it's this is because its derivative is in there, or it's in the form.
Okay.
And that's really important. I mean, there's a lot of u substitution problems, but like that's why we're doing it this way. So you solve for dx in this case. So dx is du over 3x squared. And then again, we really should evaluate the two endpoints. So u of 0 is 0 cubed plus 9, which is 9. And then u of 3 is 3 cubed plus 9. 3 cubed is what, 27? So that's 36. So we're going to integrate from 9 to 36, those two bounds, 3x squared, square root of u. And then instead of dx, it's du over 3x squared. And you see how those nicely cancel?
Yes.
That becomes the integral from 9 to 36, u to the 1/2 power du. And then this is the step when you finally integrate. I think the last time we met, like you would be given a problem like this. Now it's getting to a problem like this. So you add 1 to the exponent, just like the last problem, divide by the new exponent, 9 to 36. So this is 2/3 times 36 to the 3/2 power minus 9 to the 3/2 power. And this could require some amount of, like, comfort level with these. So 36 is really 6 squared to the 3/2 power, and 9 is really 3 squared to 3/2 power. When you have an exponent to an exponent, you multiply. So the denominators cancels. This becomes 6 cubed. minus 3 cubed. You know, 2/3 here. So it's so 6 cubed is 216 minus 27. And that is what, 16, 189, 2/3 of that. So this is divisible by 3 because they all add up to 3. So that's 63, it's 126.
Okay. Perfect.
We're gonna do D next, and then we'll come back to C, if that's
Mm.
okay.
Yeah.
Yeah, I'm gonna send you a PDF of the notes right after the lesson, so if you don't get anything down, get it back
Okay. Cool.
then, and always check your spam if you don't see it. So like what I was mentioning before is like, you don't know how to do this integral, but you kind of know how to do integral e to the u. So your u here ends up being tangent x,
Okay.
and du is secant squared x dx. And what's nice is that secant squared dx is already in the problem there.
Mhm.
Okay, so again, my strategy here is to always solve for whatever this variable is, dx. So it's du over secant squared x. And then we should evaluate the endpoints. U of 0, that's tangent of 0, which is 0. U of 1, I'm sorry, u of pi over 4 is tangent of pi over 4, which is 1. So this becomes the integral from 0 to 1, e to the u, secant squared x, and then it's du over secant squared x, like that. So it really becomes nice because they cancel, terms cancel, and you're you know, you're left with just e to the u. So this is integral 0 to 1 e to the u du, which is e to the u evaluated from 0 to 1, which becomes e to the 1 minus e to the 0, which is e minus 1.
Okay.
All right, now I intentionally skipped C because C is integration by parts. Do you remember covering that in class?
Yeah.
Okay, it seemed out of scope for this,
Yeah.
but
I don't
okay.
really understand it, but I remember it.
Yeah, I'm trying to see if there's any others like it, because we could E is integration by parts.
There might be some others. I do know that it will probably be on the test.
8. Wow. Yeah, 3 is I'll need to do that. Okay. Well, we just got to do it. This is not covered on the AP.
Oh, okay.
But it's like, if you were to take calculus 2, it's a point where most students really struggle. So it's good to see it, but only if you're going to take this class again. Okay. So integration by parts requires you to establish a u and a dv.
Okay.
And your u has to be the thing that you can take a derivative of, and your dv has to be a thing that you can integrate. And in one case, you're taking a derivative, in the other case, you're taking an integral. So this type of problem is an integral of a polynomial of x, e to the x, or it could be a sine x, or it could be a cosine x problem. But the polynomial in front, that's what your u is always whatever the polynomial is, and the dv is always this e to the x, sine x, cosine x. Now in this particular problem, your u is x cubed. But like if you get one in this form, because this is a practice test. I mean, if this is the real test, I'll just do the problems. But like if this is like in case you get one like this on the test, so you can identify it.
Yeah.
Okay, so your dv is e to the 2x dx.
Yeah.
Okay, so your du derivative is 3x squared dx. And this is where it's confusing for students, because like you take a derivative here, okay, but over here on the right, you got to find the antiderivative.
Mm-hmm.
So the antiderivative of e to the 2x is itself, but there's this 1/2 that's out in front because the derivative of 2x is 2. 2 has to multiply with 1/2 to get you back to e to the 2x.
Okay.
If that's not clear, we could review that.
Yeah. Could you just explain it again?
Sure. So let's just say off to the side here, I wanted you to find the integral of e to the 2x.
Yeah.
You would do the following. You would make u equal to 2x and du would equal to 2 dx. And you would solve. You say dx is du over 2. So this becomes the integral e to the u du over 2.
Yeah.
So this is integral 1/2 e to the u du, or you can bring the 1/2 out, doesn't really matter. But the answer is it's e to the u times 1/2. And then that u is e
Yeah.
to the 2x. So the shortcut is like, once you've done enough of these and you believe it, is you realize like, oh, the number out in front is the it undoes whatever the chain rule derivative is here. Like the chain rule derivative is 2, so 1/2 undoes it.
Okay.
Okay. And if you don't like that, then you do have to do all this other work over here off to the right.
Okay.
Okay. So now integration by parts is the following. It's uv minus the integral of v du. Have you seen that before in class?
Yeah.
Okay. So you have those pieces. You have u, you have v, you have du. You have everything you need. Okay. Now that doesn't mean it's easy. It just means you have everything you need. Your u is x cubed. Your v is 1/2 e to the 2x. Okay. But because this is a definite integral, you have to evaluate it from 0 to 1, which we are not going to do right now, but that does need to be done. Minus the integral from 0 to 1, your v is 1/2 e to the 2x times du, which is 3x squared dx.
Yeah.
So all I did was substitute in for this. Is
Okay.
that okay? Is that okay so far? Is that okay? Now on the left here, I'm just going to clean this up a little bit. It's 1/2 x cubed e to the 2x, and we're going to evaluate that from 0 to 1. Okay. We should do that right now because it's going to be distracting otherwise. So it's 1/2 1 cubed e to the 2 times 1 minus 1/2 0 cubed e to the 2 times 0. So do you see how this lower bound goes away?
Yeah.
And it just becomes 1/2 e squared.
Yeah.
Okay. Minus this integral, which this 3 goes with that. So it's 3/2 x squared e to the 2x dx from 0 to 1.
Yeah.
Now you have to do integration by parts again here. You actually have to do it 3 times. Okay. So, and it's because of that right there. Do you really want us to continue this problem or do more?
I want to give me a second to think. I want to think about what the integration by parts would be.
Okay.
See if I can.
So yeah. So we're looking at this part in blue, which I'll circle here.
Yeah. So u would be the 3/2 x squared, right?
Yes.
Okay.
Now what would dv be?
dv would be the e to the 2x dx, the same as the last.
Yes. Now because that's very good. I'm glad you see that. Because it's this p of x d of x, p of x dv in this formula up here, your u is always going to be the polynomial. Like you don't want to switch. You don't want to go back and forth. And that becomes more important in question. There's another question we're going to do, but you generally want to like always pattern it the same way.
Yeah.
Okay.
And
So it's the same formula. There's sometimes an issue here where students don't see that. Like this is, yes, it's uv minus the integral of v du, but this minus right here, it's like this now.
yeah.
So you have to be careful that you get that in.
Yeah. Exactly.
I'm happy to continue going through this, but I would recommend we move on to other question if you would like.
Yeah. That works.
Okay. Just a moment here. Okay, so next question. is on the next page. Come on, load. All right. Oh, good. So 2E, is there a 2A through E, A through D?
Yeah, it might have just messed up the pages, but there is a 2A through D.
Really? Okay.
The A is like 7 square root of tan, arctan of some sign I don't know the name of.
Oh, there it is. Yes.
So,
Okay. Yeah. All right. Yeah, let's do this. This is way longer than a normal exam.
Mhm.
Just to give you some like
No,
kind of,
we have a 55-minute class period. I don't think they would be giving us.
no,
Hope
not even close. This is way too many problems to ever be
like
asked to do.
4 or 5.
Yeah. So your U here, do you have any idea what your U might be in this problem?
Oh. Um, there's a lot that it could be.
So there's some rules here. Like it's sometimes what's in parentheses. It's
Okay.
sometimes what's in exponents. In
Okay.
this case, it's what's under the root.
Okay.
It could be denominators.
Can.
Yeah. Now the true answer here is that whatever it is, when you take its derivative, the derivative better be in there in some form. So the derivative of this is 1 over 1 plus alpha squared. And maybe you can kind of see that over here on the bottom. Yeah, I know there's 5s, but maybe you can kind of see that.
Yeah.
So your d alpha is 1 plus alpha squared times du. Now we're ready to go back in and substitute in. So it's 7 square root of u over, and this time I'm going to factor out a 5 because you can kind of see that here. 5 alpha squared plus 1, and then your d alpha is 1 plus alpha squared du.
Okay.
So hopefully you see, oh, those cancel. And this is just the integral 7/5 u to the 1/2 du. It's pretty common that they become really simple. There seems to be the instructor used too many u to the 1/2s here, but it's okay.
Yeah. Some kid put this together. One of
Oh,
the students
okay.
who took years ago put it together.
I see. Well, I'm glad I knew that. So I should have done the previous problem. We should have done the previous problem with just an X. That would have been more consistent with what you might see on an
Okay.
exam.
Yeah. These
Okay.
questions are probably a little bit harder than what I will actually see.
Yes. So you add 1 to the exponent, 3/2, and you divide by the new exponent, 3/2, plus c because it's a indefinite integral.
Yeah, because there's no points on
Yeah,
the
there's no upper and lower bound, right? So that's really important. And then you got a simplifier here. It's 2/3 times 7/5. Then you need to back substitute your u. And sometimes you forget what your u is. You just go back and look. It's arctangent of alpha. Yes, you have to do this. So like, just always know that you're going to back substitute. And then, 14 over 15 arctangent of alpha plus c.
Okay. And that would just be my answer.
That's your final answer there.
Gotcha.
Okay.
So when it's an indefinite integral, we do the plus c and we backtrack to our u.
Yes.
Yeah.
You always want to go back to original variables. So like,
Okay.
if you take more calculus, there's other techniques of integration where you just you transform between variables, and you always go back to whatever you started with.
So you always go back. In this case, you just didn't plug in the upper and lower bound.
Yeah, well, but we go back to the original variable of alpha. You don't leave it in terms of u. Like if you stopped at this line right here, you'd get, I don't know, 8 out of 10, 7 out of 10, because you didn't
Gotcha. Okay.
go back and do it. Okay, what do you think your u is in this problem here?
Okay, so there's no parentheses. No. Would it just be t squared?
It's t squared plus 5. It's gonna be the whole denominator.
Will you include the plus 5?
Yeah,
Okay.
it's generally you add the term, because you might be thinking, oh well, if I take the derivative, that's 2t, that's that's good, that's true, but yeah, it's generally the whole thing.
Gotcha.
So du is 2t dt. dt is du over 2t.
Okay.
So you integrate t over u. dt is du over 2t. If your variable doesn't cancel, most of the time that means you didn't do it right. There's a couple of exceptions to that, but I haven't seen it yet. So those cancel, and you have 1/2 on the outside, integral 1 over u du.
So the u's wouldn't cancel.
It's du. It's
Oh,
du. Yeah, du is that thin slice when you're finding the area under the curve.
okay,
That's what that is. It's that thin slice.
gotcha. So then
So this is a special like known one. Do you remember what this is?
that's the natural log of u.
Yes, and the absolute value, very important.
Absolute value. Yeah. Okay.
That's also one if you don't do, that's kind of a big deal.
Yeah.
To
That one
have
I
that.
got pretty well memorized from last test. It was on
Great.
there a little bit.
Great. Yeah. So now you back substitute your u. Your u is 2t squared plus 5. So it's 1/2 natural log absolute value t squared plus 5 plus c, and you're done.
Awesome. Okay. That one I get very well.
All right. We should do a variation on D.
Okay.
Is the goal to go through all of these? I guess I should ask, because we can do C next.
Not all of them per se, but a decent amount. To
Okay.
where if you see two that are very similar, pick the harder ones that'll be able to
Okay. Sure.
do the other one as well. If that makes sense.
Okay. So before I do that, let me just tell you what the U is in question C, in case you want to do it later.
The natural log x,
Yes.
since it's in parentheses.
Yes.
Okay.
And it works out pretty nicely after that. Okay. So this is an integration by parts problem. And I think there's actually a lot of value in like identifying it. Do you play sports?
Yeah, I play soccer.
You play soccer. So like maybe you look at the defense and you like, oh, when it's this, I do this. Or if you see a player doing something, you like there's value in like being able to understand that this is an integral of p of x, which is a polynomial, times the natural log of x. This is different than the ones I was showing you earlier.
Yeah.
So when it's this type, I call these types, your u is always, this is different, it's natural log of x. Your dv is p of x. So if you remember from the previous problem, I said, oh, when it's let's go back and look at it. Whenever it's this like polynomial of x times an e of x or a sine of x or cosine x, your u is always the polynomial and your dv is the other thing.
Mhm.
Now it's switched.
Gotcha.
Okay, and you have to know this, because if you do it the other way, you will never get the right answer.
Okay.
Okay, so your du is 1 over x dx. And I'm sorry, your v is,
Sorry, one quick question.
yeah.
The u, it would just be natural log of x, not natural log of x.
Sorry.
Oh, okay.
Yeah, sorry.
Okay.
So yeah, so so the derivative is, let me do this correctly. It's 1 over 5x. The derivative of 5x is 5.
Yeah.
So it ends up being 1 over x dx.
Yeah.
But yes, that doesn't matter. Okay, so your v in this problem is x to the 5th dx, your dv. So you have to find the antiderivative of that. And this is where it's like you're going back and forth between what you learned like the whole year, and now it's different. So it's x to the 6th over 6.
Okay.
Is there anything in this that's unclear, or when you go over again?
Let me just look at the dv really quickly and see if I get it. Sorry, why is it x over x to the 6 again?
So the integral of x to the n is always x to the n plus 1 over n plus 1. You add 1 when you're taking an integral. And dv, we're actually integrating both sides. I guess I didn't show that.
And then we just get rid of the.
Yes. Get rid of that. Okay.
Gotcha.
So now this UV minus integral V to U. I try to box in stuff that's like rules or like maybe go on a cheat sheet kind of thing. You have everything you need here. You have your U, you have your V, and you have your DU.
Yeah.
Okay, so your U is natural log of 5x. Your V is x to the 6th over 6th minus the integral. Your V is x to the 6th over 6, and your DU is 1 over x dx. No calculus there. I just move pieces around.
Yeah.
So on the left here, this is 1 over 6 x to the 6th natural log of 5x. That's just a rewrite. There's no calculus there. Just simplifying. And then here, it's 1/6 because of that. And then it's integral x to the 5th because you got 6 on top, 1 on the bottom, dx.
Yeah. Okay.
So this right over here in blue, I'll change this to blue here. It's that we just did one of those over here kind of. It's x to the 6th over 6th plus c.
Okay.
Okay, so it's paired with this 1 over 6. So it ends up being 1 over 6 x to the 6th natural log of 5x minus 1/6 times x to the 6 over 6 plus c. And that's your final answer.
Okay. And we would just merge the, yeah, okay.
Yes.
Combine. Okay. Got it. Yeah.
Okay. Give me just a moment here.
No problem.
See which one to do next. Yeah, I remember how we were doing. So there it is. All right, let's do a 2E now. This is the other type of integration by parts.
Okay.
There's really 3 types that are generally taught. We've covered 2 of the 3. This is the 3rd of the 3. Yeah, so let's do this. So this is the type where it's an e to the x, and it could be sine or a cosine. So your u is going to be, you actually could do it either way. I prefer to take derivatives of whatever I guess the more complicated one is. And that's slightly more complicated because the other one, you have to find the antiderivative of each time.
Okay.
So we end up doing integration by parts twice on this, and we're going to use the same u and dv pattern, meaning the u is always going to be this e and the dv is going to be this other thing. So your du is e to the 3x, but chain rule, you put a 3 out in front, dx.
Mm-hmm.
And on the right here, you're integrating. So your v is minus cosine x, because the derivative of minus cosine gets you back to sine.
Mm-hmm.
Take a look at this and let me know if there's anything that you would like me to clarify.
No, that looks good.
Okay, so it's uv minus integral v du. We have everything u, we have v, we're good. So this time I'm going to actually rewrite this integral off to the left here. You'll see why in a few steps. Equals, okay, so your uv is e to the 3x times minus cosine x minus integral minus cosine x 3e to the 3x dx. So just cleaning up a few things. This is minus e to the 3x cosine x. These two negatives go together. So it's plus integral 3 cosine x e to the 3x dx.
And you get the 3 out in front of the.
You can, but I'm going to leave it in here because, and you'll see why. Because we have to do integration by parts again here. If you take it out, you end up having to multiply in each thing.
Okay.
And it's easy to lose track of stuff.
Yeah.
So this is what I was trying to mention here is you let your u be e to the 3x again, because it was E, but you want to add in that 3 out in front.
Okay.
And your dv is the other thing, it's the cosine x. So I was trying to say, and I haven't done a very good job, it's like you keep your u kind of in the same family and your dv in the same family.
Okay.
Dx. So now your du is e to the 3x. Here's your 3, but then you have another 3 from chain rule there.
Mhm. Okay.
So your du ends up being 9e to the 3x dx. The antiderivative of cosine is sine. Thank goodness, it's not too bad. Okay, and I'm just going to switch to blue again. uv minus integral v du. And we're using all this stuff over here to the right.
Mhm.
Okay, so it's 3e to the 3x sine x minus integral sine x 9e to the 3x dx.
Mhm.
Okay, and I'm going to start bringing stuff down. Minus e to the 3x cosine x. I'm going to bring this down. Is the blue okay? Because I was just carried through for the rest of the problem.
Yeah.
All right, so this 9 right over here, we are going to bring that out.
Okay.
So it's minus 9 integral, and I'm going to rewrite slightly, e to the 3x sine x dx. And then we're going to keep all the other stuff. Just move this down slightly. Okay, so we've done a lot of work, and this is the most critical step here. Like up until now, nothing really has mattered. That like this is really what matters. Do you see that this integral over here on the right is the same as this one on the left?
Yeah.
So this particular style of problem, what you are doing, which isn't quite correct, is you're adding integrals.
Mhm.
You're adding it to both sides of the equation. So when you add it over here to the left, how many do you have? You have 10.
Oh, 10.
Yeah.
I'm thinking of the other.
Yeah, it's weird. So you have minus e to 3x cosine x plus 3e to the 3x sine x. Okay. So now, like your answer is over here to the right. Okay. But you got this 10 out in front. So how do you undo that? You divide both sides by 10 or whatever number you end up getting over there.
Okay.
So because you got the same thing over here on the right, and that always happens, you always do this integration by parts twice. You always add it or subtract it depending on how the signs work out, and then you divide back over your that whatever that number is. So the final answer, the integral of e to the 3x sine x dx, that was our starting problem, is exactly what you have here, with just a little extra. You got to always include that. Oops, that didn't work out very well. Let's try it some more time. Okay, that plus c.
Okay. Okay. A little bit more work for that one.
Yeah. It's a, like, normally you get one u substitution, one integration by parts problem on these exams. The way this thing is written, which he says from a student, I mean, that's not how it's going to be presented in a test.
Yeah.
Because these are really long problems. They're not short, a lot of steps.
Yeah. There'll probably have to be one.
Yes. Okay. What's G is a good problem because of its order. F is also kind of okay. F's actually kind of weird. Let me look into that. Oh no. Have you done any partial fractions
Um,
in
I'm
this class?
maybe.
It's way past. I mean, it's not way past, but it's like the next thing you might see after integration by parts. That's what
Um,
I'm asking.
we might have sometimes.
Okay.
Yeah.
Okay.
Um,
Well, I'll show you 2F then. So as I was mentioning, like that's the challenge here is this is a partial fractions problem. And unless you've done a bunch of these, you wouldn't know that in advance. So this 25 can actually come out. So it's 25 integral 1 over x squared minus 25 dx. And you're supposed to recognize that the bottom can be factored. X minus 5, x
I
plus
think we
5.
have a little bit of this.
Okay. So this one and this so like we've done some calculus. Now we're gonna break away from the calculus and we're gonna come back to it. 1 over x minus 5 times x plus 5 is equal to a over x minus 5 plus b over x plus 5.
Yes, we have done this.
Okay, and we have enough information to be able to do this. So on the right here, you make a common denominator. So you're effectively multiplying the top and bottom by the other one.
Yeah.
And this is x plus 5. This is x plus 5. So what it becomes is a x plus 5a, because I'm distributing in, plus bx minus 5b. Okay. And you actually don't care about the bottom, but the bottom is x minus 5 times x plus 5. And that equals, over here on the left, the same bottom. Now the top, I'm going to write slightly differently. It's 0x plus 1. The reason you have to do that is because you're going to set up a system of equations. And this is only one way that you could be doing this. There are a couple other ways.
Okay.
So your 0 is in front of x. So you're matching, let me do this in red, you're matching any of your x terms. So your 0 is a plus b, because there's really an x here in front of this, to the right of the 0. It's really ax plus bx. Then the plus 1 goes with the non x terms. So it's 1 equals 5a minus 5b.
Okay.
So how do you solve systems? Like what's your go-to, if anything, here?
I would probably use the top equation to get either a or b, and then plug that into.
Sounds good. So let's just solve for a. So a equals minus b. So this is 1 equals 5 times minus b minus 5b. 1 equals minus 10b. So b equals negative 1 over 10. And that means a is equal to the negative of negative 1 over 10, which is 1 over 10. It can feel like, oh, I'm done, like, but not really. This is just like the little piece of it.
It's like the algebra part.
Yep. So we go back to this line right here, and we bring it down, right, all the way down. And so what we're doing now is the integral 25 integral 1 over 10. I think I did x minus 5 plus negative 1 over 10 x plus 5 dx. And that's a and that's b. I didn't. There's other ways to write it, but that's how this is. So you could multiply the 25 in. You could have actually used 25 also in this instead of 1. That's not important here. Just however you decided it was fine. Each one of these, though, what you're doing is the integral of 1 over, in this case, like x plus a number. This always becomes the natural log of the absolute value of x plus that number.
Yeah.
So this first one is the natural log of the absolute value of x minus 5. that 1/10 comes out in front, and then that 25 is right there also.
Mhm.
Plus minus 1/10 natural log absolute value of x plus 5 with that 25 at some point plus c.
Okay. And then we just leave it like that.
That is your final answer.
Okay. Okay. So you kind of just take what you did and plug it back in.
Yes, you have to, you find a, the reason you find A and B is because you can't integrate this thing that we started with, but you can integrate A over x minus 5 and B over x plus 5.
Yeah. Yeah. Okay.
And the reason we could do that is because of this factored nicely. If it doesn't factor, there's other ways to do it, but that's just another, approach.
Yeah. Okay.
All right. G, we should do G. This, I don't know if the student or whoever made this like intended this, but when you're doing so many of these problems in a row where it's like, oh man, you like, so far we've done a lot of u-substitutions, integration by parts, and then we did a partial fractions. You can sometimes miss the obvious here. So because you're so used to this, but if you divide both of these by x squared,
Mhm.
it's actually a problem you could do last chapter. This is x. This is 5x to the minus 2. And these are really simple integrals. They're power rule integrals. Right? You just add 1 to the exponent and divide by the new exponent.
Yeah.
So this is x squared over 2 plus 5. You add 2 to, or you add 1 to -2 over -2 plus 1, and then plus, always a plus c. So this one's x squared over 2 minus 5 halves x to the minus 1 power plus c.
Okay. Hey, Dad. I'm on a
Come in.
tutoring session.
Okay.
Okay.
So maybe pick and choose the ones like like on your exam, like look for something really easy to start out with, or
Yeah.
don't.
Just go through and like look for just obvious.
Yeah, like, oh, this is a u-substitution. That's a good.
Because then I might get lost in the complicated ones and try and do
Yeah.
that on the easier ones.
Yes.
Okay.
So, okay, let's see here. So, H is a really hard partial, not really hard. H is another partial fractions. We probably should have done that one first. We can do H, or we can go on to 3. I don't think 3 is a very good problem. Well, we could do those. 4, A and B are good.
Okay. Let's go to 4.
Okay.
Wait, quick question. On 3, when it says evaluate by using a substitution and then integration by parts, what does it mean by a substitution first?
So you're going to make a u-substitution there of x cubed,
Oh, okay.
but then you're going to see that it doesn't cancel.
Oh,
Let's, I mean, if we're going to talk, I'll show you, you're going to see that we don't want to actually do this because I think it's a bunch of integration by parts. But let me show. So your u is x cubed and your du is 3x squared dx. Okay, so you integrate here and you say, okay, it's x to the 8th cosine u, and then dx is du over 3x squared. So you're left with 1/3 integral x to the 6th cosine u du. And I mentioned this a couple times where I was like, well, if you don't get rid of all your x's, that means you probably did something wrong. This is the exception.
okay.
So you go back to this line right here, u equals x cubed. And can you make an x to the 6th? Yes, if you square both sides. So u squared is x to the 6th. And so this becomes the integral of u squared cosine u du with this. And this is integration by parts twice.
Okay. Okay. Gotcha. Do I then plug the? No.
No, so you do your integration by parts, but you will eventually back substitute u equals x cubed into your final answer.
Okay.
And this one's a little wonky because you want to use u and dv for your integration by parts. So if you were to get this on the exam, I would tell you to like make this y squared cosine y dy to just kind of get out of use, because you can mix your variables.
Yeah.
Easily.
Okay. Okay.
All right, so I think oh, I already snipped that one. Let's see if I can find it here. Where did it go? I don't know. I'll re-snip it in. You're really at a point where you guys could just start reviewing for the AP. I mean, this is like total filler for class time, but that's what it is. So this is called a, sorry for moving around too much. This is called a separable differential equation, and separable means that you can separate the variables. So you want all the y's on the left, and then you want all the x's on the right. And you generally do this by multiplying or dividing. Okay, so in this case, you're going to divide both sides by y over 1 minus y.
Okay.
And then you are at the same time multiplying both sides by dt and dt. So on the left, on the left here, you get dy over y times 1 minus y equals 1 dt.
Okay.
Is there anything there that's uncomfortable or doesn't look right?
No.
Okay. All right, so on the right, you can integrate this. This becomes t plus c, t to the 1. This is the easy one. On the left, this is a partial fractions.
Okay.
So it ends up being integral. Integral 1 over y plus 1 over 1 minus y.
Yeah.
And you can confirm that later. It's not just because of this. It actually just does work out nicely like this. So this becomes the natural log of the absolute value y plus the natural log of the absolute value 1 minus y. But see how there's, when you take the chain rule derivative in here, there's a negative, so you have to put a negative there. Equals t plus c. And this is probably correct, because you would generally try to solve for y, but you can't in this case.
Yeah.
So so we would say, okay, we're all done here. Like this is our answer. Usually we're done here, but there's this initial condition. See this y of 0 equals 0.1.
Mm-hmm.
So they're saying when x is 0, or t in this case, when t is 0, y is 0.1. So it's natural log of 0.1 minus natural log of 1 minus 0.1 equals 0 plus c. So on the left here, this is the natural log of 0.1 minus the natural log of 0.9 equals c. And if you remember, natural log of a minus natural log of b becomes natural log of a over b. So this is natural log of 0.1 over 0.9 equals c. And that's your final answer. So the natural log of 1/9 is c. So you would take this value and plug it back in this line right there. Or sorry, actually the one above it, this one up here.
Okay.
Unfortunately, we have to stop here. I guess we've got a lesson tomorrow scheduled, so we can pick up here, do some new stuff, whatever you want.
Yeah.
All right. Well, thanks so much for scheduling, and I'll see you next time.
See you tomorrow. Bye.
Okay, bye now.